Hey everyone, today I'm going to talk to you about parallelograms, the properties of parallelograms. In simple terms, a parallelogram is a polygon formed by two pairs of parallel sides. And those parallel sides are going to be congruent to one another. Okay, so you know two parallelograms, rectangles and squares. You know a rectangle, the tops and bottoms are congruent, and the sides, the left and right sides, are congruent. In a square, all four sides are congruent. Both of those are special types of parallelograms. And for the angles, the inside of the angles, those are like alternate interior angles. When we covered that a few chapters ago, the alternate angles like Q and S are going to be congruent. R and P are going to be congruent. Sometimes they're all the same angle, like if it is a square or a rectangle, but it doesn't have to be a square or rectangle to be a parallelogram. As long as you have some sort of polygon and the opposite angles are congruent to each other, you'll know it's a parallelogram. Okay, and all that's kind of justified by the alternate interior angles theorem that, like I said, that we covered previously. And we also covered consecutive interior angles. So imagine QR and PS as my two parallel lines. So that makes angles X degree and Y degree consecutive when they're next to each other. They could also be consecutive working from left to right, from Y over here and X over there. Those are going to add up to 180. And if you notice, it's the same letter going across, looking at it diagonally. So consecutive angles are supplementary because consecutive interior angles are supplementary. And then diagonals. Diagonals bisect one another. Bisect means they're perfectly cut in half. So you might have all four diagonal segments are congruent, but you could have two pairs that are congruent. That's why they're marked with one line and two lines, because they're not necessarily going to all be the same. But like I said, if they bisect each other, then they cut each other perfectly in half. The last one to go over is this property goes over diagonals. Again, this property says if you have one diagonal, then you're forming two congruent triangles. And so you would work with it like that. You could kind of, I guess, flip it in your head and stack them side by side rather than have them, because you have one that looks upside down when it's compared to this one over here. That pretty much covers all the properties of the parallelograms in this example, so in these notes, I mean. So let's just dive into the examples. Here I have a basketball hoop, and in the mounting mechanism, it forms a parallelogram. And I'm given that angle A equals 55 degrees, side BC is 1, and side AB is 2.5. So 55 degrees, 2.5, and 1. Okay? So I'm just asking you, what is side DC? Well, DC is underneath AB. So DC is 2.5. 2.5. Measure of angle B. Where is B? B is next to it. It's consecutive. Okay, so consecutive means it's supplementary. So supplementary adds up to 180. So I'm going to go 180 minus 55 equals 125 degrees. And then angle C is diagonal from it, so that means it's congruent, so that means angle C is 55 degrees. Alright, whoa. Let's move on to the next example. If QRST is a parallelogram, find the value of the indicated variable. Okay, so let's solve for x. Notice how you have 5x on the outside and 27 on the outside. So parallel sides are congruent. So opposite sides are parallel and congruent. So 5x equals 27. Let's just divide out that 5, and I get an answer of 5.4. There we go. Let's look at the y's. Here I have the y's on the inside of the diagonals. So that means diagonal segments are congruent to each other. So I'm going to set these equal to each other. So I'm going to write 2y minus 5 equals y plus 4. let's see here, I can subtract this y over here, and then I can add 5 over there, and I will have gotten everything to one side. So I get 2y minus y is y, 4 plus 5 is 9, so y equals 9. Alright, and then let's figure out z. Okay, so here's 3z, and then you have 95 and 33. Well, remember, you want to go with the alternate interior angle. So if you're going to alternate, you're going to go across to the diagonal. That'd be like your transversal if I were to relate that back to an earlier chapter. So I'm just going to write 3z equals 33. And then 33 divided by 3 is 11. So that's it for that one. Here I have another parallelogram, and the x's are consecutive to one another. So consecutive means they are supplementary. So supplementary means they add up to 180. So 4x plus 2x minus 6 equals 180. So that makes 6x minus 6 equals 180 when I combine like terms. And now I just need to add 6 to get rid of it to both sides. This is a plus 6 there. So 6x equals 186, which means now I need to divide by 6. And 186 divided by 6 is 31. Okay, so what I'm going to do to figure out the angles is just do 4 times 31, which is 124. And then I'm going to go 2 times 31, which is 62. 62 minus 6 is 56. And so when you add these back up, they should equal 180, which 124 plus 56 does equal 180. All right? And now I need to do the y's. So I have this side on top and this side on bottom, so they must be congruent. So I'm going to write y plus 8 equals 5y. Y plus 8 equals 5y. All I have to do is just subtract this y over here, and I get 8 equals 4y. So divide by 4, and I get 2. So if y equals 2, then what's 2 plus 8? 2 plus 8 is 10. What's 5 times 2? That's also 10. So you know you did it right when they're the same thing. So 10 and 10. Alright, and here I have z on diagonals. Diagonals bisect each other, meaning they're perfectly cut in half, meaning this segment is equal to that segment, so 3z minus 4 is equal to z plus 5. Let's get our z's to one side. Let's add z over. Sorry, subtract that z, because it was a positive z. And then let's add this 4 over. Cancels, cancels. 3z minus z is 2z. 5 plus 4 is 9. Divide out the 2. You get z equals 4.5. Plug z back in. 4.5 plus 9 plus 5 is 9.5. That's kind of a weird looking 9. 9.5. Hey, this one's still weird looking, but I'm okay with it. Then 3 times 4.5 is 13.5 minus 4. That's going to be 9.5. So we send them equal to each other, so when you plug it back in, they should equal the same thing. And that's it for the notes. Goodbye.